Hello friends, my name is AJ and welcome to the second video in Carolina Analytics and Data Science's Introduction to Python for Data Science series. In this video, we're actually going to be jumping in and working with a little bit of Python code, and we're going to be talking about how we can store data inside of our code and inside of our programs. So without further ado, let's get started. All right, everyone, so as you can see, I'm inside of a Jupyter notebook here in Jupyter Lab, which is the program that we set up in the last video. And if you recall from last video, talking about headers, I do have three headers here, one for the video title, as well as the two main topics that we're going to be talking about today. And we also have two code cells where we will be working with our code. Now, you can set up a similar template to this, or you can just create a new notebook and follow along using our code cells. Regardless, this is just here for organization purposes. All right. So the first thing I want you to think about here is pretty much any time you use, any sort of program, whether it be a phone game such as Flappy Bird or a more complex program, the program is always keeping track of some sort of data. For example, in a video game, you might have a high score, and that high score is data that is stored every time you load up the game, or every time that you, for example, supersede your high score might change, so you might have to access and modify some sort of data. There's also many other things, such as if you play video games such as Minecraft, where you have an inventory, keeping track of all of the items that you own. That's something in various games. That is also keeping track of data and being able to not only access data, but also manipulate it in some way. In addition, in more of an academic standpoint, let's say you have an app or a program for an encyclopedia, such as an encyclopedia of birds. You might have the name of the bird, the genus and the species of the bird, some information, where it might live. All of that is data that you need to be able to keep track of and access whenever you're using your program. And whenever you are using any of these programs, all of this data is kind of being accessed, created, stored, all of that in the background. So the idea of a variable is simply a container in which we store some sort of value in. And I want you to think about it like a box, if we use this analogy. You like a cardboard box, let's say in the attic, in the basement, maybe in a closet somewhere, wherever you put your boxes. A cardboard box, for example, always has something in it. You put something inside of the box. And then in the outside of the box, you might add a label to it, so that when you are looking through your boxes later, you can figure out, well, okay, this is what is actually inside of the box. It's easy for identification purposes. And these two standard things, the label as well as the contents of the box, works perfectly well with a variable as well, or that's kind of how variables are set up. So you can see in our cell here, I'm just going to be typing in something, which is going to be name equals value. Okay, so this is the standard format, or the standard formula, if you will, that we use to create a variable in our code. And basically what we're doing here is we have some sort of value here on the right side, something that we're actually going to be storing for later so that we can access or modify in the future. And this is essentially similar to the contents of a box that I was talking about earlier. And then next to it on the left, we have what is known as the assignment operator. And this is a fancy term. Of course, this is just an equal sign. But this is basically assigning the name on the left to this value. And if we go back to the analogy, the name is similar to the label on the box, right? You're basically labeling your value here so that you can actually find it and access it later. So for example, I'm going to create a new cell below this one, and I'm going to follow this format to create a variable. So let's say I want to make a variable named x. We're just going to call it x in this case. Now, in general, when you're making your variables, you want the names of your variables to be somewhat descriptive. Meaning that, let's say I am storing the number of passengers on a plane, you'd actually want to probably, rather than just name it some letter, you'd probably want to name the variable, for example, num passengers on a plane. And I will show that here. So for example, let's say I want to store a value of 8 right here. What we're doing in this line is we're taking the value 8 and we're basically giving it a name of x. Okay, we're basically storing the value of 8 as x. X is the name for this value, meaning now that if I want to ever access this value again, it has been stored with the name of x. So I can always go back and access it. So for example, I'm actually going to run this cell over here. And you can see now that when I run it, the number changes to 1. And let's say that I want to access my number. Now, I've stored my number as this variable x. Let's say this is somewhere and then there's some long program, but I want to actually now access this value. Well, what I can do is I can actually simply just type x inside of my cell and run it. And you'll see that the output that it gives here, you can see the output is red while the actual code is blue here on the side. You can see that my output, it outputs the value of 8. Now, this works very well, and this is one of the very good things with Jupyter Lab. You can actually see output simply by putting a variable, for example, just at the last line of a cell. So you can see here that because the cell only has, one line in it, that is why this is considered the last line of the cell. And by putting this on the last line, it prints out the value. Now I can do that here as well. So you can see when I ran this the first time, it gave me no output. But if I write x again on the bottom of the cell and I run it, you can see that it gives me the output of 8. Now what I'm going to do here is in my second cell, I'm going to go back to the idea of number of passengers on a plane, right? Let's say I'm analyzing some data and I get that I have 255 passengers on a plane. Well, that's great. But if I were to again run this, you can see it outputs 255. But then later on, if I have another cell and I want to access this, I'll never be able to get this value again. And that is why we create a variable to store that value for us so that we can access it later on. So in this case, I'm going to give my value, I'm going to store it in a variable. And I'm going to call this variable number of passengers. Number underscore passengers. And I'm going to set it equal to 255. So now if I run, remember you can run by either pressing this play button or by using Shift Enter. You can see now that this is the 5th cell that I've run. And now the value 255 has been assigned to the label or to the variable number of passengers. So now later on, I can actually access this by saying num passengers, just like that inside of my cell. Now, another way to do this, this is one way to get output. However, let's say that you want to get the output of a variable and it's not the final line of a cell. You can use the print function. Now that sounds very fancy, but all you do is you simply write print and then surround the name of the variable whose value you want to actually display. You want to surround that by parentheses. Now this in notation when it comes to functions. We'll be talking about that in a future video, but just know that if you want to get the output of a variable, or you want to get the value out of a variable, this is one way to do it. You can say print, open parentheses, close parentheses, and then in between the parentheses, you can put the name of the variable. So you can see now that when I run this, it gives me the same output of 255. Now, this is just a number. There are many different types of data that we can actually store inside of variables. And that gets us to the next part here, which is known as data types. Okay, now data types are it sounds essentially what it means. It is the different types of data that you can store inside of variables. And there are 4 basic ones that we're going to going to start out with. And these 4 basic data types are essentially probably the most common data types you will face, especially as you begin working with Python. And so there are 4 here, which I'm going to mention. Now, by the way, one very important thing to note is that in your code cell, if you want to actually type text and not give an error, like for example, if I were to say this prints or this displays the value of a variable, just like that. If I were to just write that text in my code cell and then run it, you'll see that it gives me an error. And that's because Python is looking at what you typed here, and it's trying to read this as code and trying to run the cell. And because this is not actually code, it's just text, it gets very confused. You can see it says invalid syntax. Syntax refers to the way that you write. So in this case, it's saying that this is invalid or not correctly written. So the way that we can actually write text inside of our cells is to add a pound symbol in front of our text right here. And this creates what is known as a comment. So you can add comments or notes essentially inside of your cells and Python will simply disregard it. It will not try and run this it will not try and actually run this as code. It knows now that this is a human text and therefore will ignore it. Now, why is adding comments useful? Well, comments are very good to essentially explain what you're writing. For example, if you're writing a code that has 100 lines or something, and you want to actually, explain what your code is actually doing, you can add comments before some of your lines. And what that'll do is that it makes it more readable. For example, if you stop working on a project and then come back to it, one year later, for example, and you're reading through your code, if you didn't leave comments for yourself, you might have no idea what anything means. However, if you leave comments for yourself, in the future, you might be able to read the code and say, oh, okay, this is what this does. I may have forgotten because it's been a year, but the comment that I left, a year ago will now be able to help me. This is also very useful if you're collaborating on coding projects. Leaving comments for your teammates or whoever you're working with is really, really important. And it allows everybody to be able to understand code that, everybody writes a little bit easier. So here, what I'm doing is I'm essentially creating a comment or 4 comments by doing this. And I'm going to be typing out the names of the 4 most common data types. So the first one is going to be an integer. And an integer data type is essentially a whole number. A whole number. So a whole number can be anything from, it can be negative, it can be positive, but it cannot include a decimal place. So for example, if you look up here with x equals 8, the variable x that we created, and the variable num passengers, both of these are integers because they have whole number, or the values inside of them are whole numbers. So for example, if I want to create another int, my int, this can be equal to, for example, any number. Let's say I do -88. And this will be here an integer. Now, how can you actually check what data type variables are? Well, to do that, we can, and I'll write here, how to check the data type of a variable. You can use the type function. So you see here how we used print. We can use that same idea, but use type instead. Type, open close parentheses, and then my int. So I put the name of the variable in here, and when then I run my code, you'll see that it outputs integer, or int in this case. Now, the second most common data type that you might find is what is known as a float. And this is a number with a decimal point. So basically any number that's not a whole number. So for example, I can say my float, I can set this equal to 8.2, for example, right? And if I were to take my float and put it inside of my type function, you will see now that it outputs float because the value that I'm storing inside of my float is a number with a decimal place. And this can be many decimal places. For example, I can say approx underscore pi and set this equal to 3.141592, just like this. And if I run my code, you'll see that it stores the value. And I can always put approx pi in type. Sorry about that. Let's copy this and paste this and run. And you'll see that it again outputs float because it is a number with many decimal places. Now what I can do here is I can type print approx pi now above type, and you'll see that now it gives me the value. See, it displays the value of my variable here as well as tells me that it is a float. And that is very, very useful, especially if you are working with many variables. Knowing the value and the type of the variables might come in very handy when working with different numbers and different data. Now, one thing which I want to point out, and I'll call this challenge. What would you think that the number 6.0, what do you think that would consider as? Is this an integer or is this a float? Now, this is something that is very interesting, because if you were to use the value 6.0, well, that is technically a whole number. However, the definition of a float here is not just a non-whole number, but is a number with a decimal point. In this case, even by saying 6.0, just including the decimal point here automatically will make it a float. And I can show you this by putting challenge inside of my type variable, and you'll see that the print gives me the value, and you can see that the type is still a float. So that is something that might be useful to know. Now, the next data type, which is very common and we'll be using extensively in future videos, is known as the Boolean. Now, this sounds rather complicated. However, this might actually be the easiest of the data types, because a Boolean is simply a binary choice. What do I mean? Well, think of a light switch. You can have on or off. Only two possible values. That's it. On, off. Yes, no. True, false. That is essentially what a Boolean is. There is a state that is either on, yes, or true, and then there's a state for example, off, or no, or false. There can only be two possible values. And in Python, the values are referred to as true and false. True, of course, refers to some statement being true or correct, yes, on, etc. And false would be the opposite of that. So for example, if I were to say my Boolean, I can set this to true, and I can create another Boolean that equals false. And the way that you type it is true with a capital letter and false with a capital letter. And again, these are the only two values that can be stored as Booleans. These are the only two values that Booleans can take. If I were to put anything else in here, then it would not be considered a Boolean. It would be simply not a Boolean. A Boolean can only have two values, true or false. So here, if I were to print out the value of my Boolean and the type, you can see that it gives me the value of true, as well as that the type is a Boolean. It is, in this case, BOOL refers to a Boolean. And now the last data type that is obviously very, very common is a string. This is our text. So string, this is text. And of course, this is, very, very important, because text is one of the most common data that we not only store, but also transfer, edit, etc. So for example here, I can type in university, and I can set this equal to University of North Carolina at Chapel Hill. Just like that, right? And now if I were to run my code, you'll notice that we get an error. Now, why is this? Well, I put my text on the right-hand side of the equal sign. I have the name of my variable. Oh, that looks good. Well, the reason is because whenever we want to refer to text in our code, we need to surround our text with quotation marks. Now, it doesn't matter which one you use. You can either use the single quotation marks like this or the double quotation marks. I personally prefer double quotation marks, but single quotation marks is the standard in Python. And the reason that we do this, and you can see now if I were to run my code again, I'll put this in print and type, you can see that it prints out my text, University of North Carolina at Chapel Hill, and says that my type is a string, or str. Now, let's compare. I want to compare these two lines. University equals University of North Carolina at Chapel Hill, with quotes and without quotes. Well, the reason why we need quotes is because if we remove the quotes, then it's essentially counting every single one of these words as separate variables. Because you see, if I can say, university equals UNC or University of North Carolina at Chapel Hill, I can then refer to my variable just like this inside of any function or anywhere else in my code using this name. So if I were to just have no quotes here, it's going to think that every single word is essentially a variable that it's referring to. And because there is no variable called university with a capital U, remember these are case sensitive, so just because this is lowercase, all lowercase is different from all uppercase in this case. So this here, it will simply try and find variables with these names, and it does not exist. That is why in order for Python to understand that we're talking about text, we need to surround it with quotation marks. And that is very important. All right, everyone. So now we have gone over the 4 main data types that we will be looking at throughout or at least the beginning of this series. We have the integer, which are whole numbers. We have floats, which are numbers with a decimal point. Boolean, which is again either true or false and only one of those 2 values. And then strings, which contain our text. We also talked about the importance of making sure that we have quotation marks around our string or our text so that Python knows that we're actually talking about text and not referring to anything else in our code. We also went over the print function, which allows us to see the values inside or see the values of variables, and the type function that allows us to see the type of our variables. And now the last thing that I want to go over, which I will actually be going back all the way to the top here and making a note of, is actually how we name our variables, or the naming convention. Because oftentimes, once you see that you can say name equals value, people will try many different names. For example, instead of num passengers, which is you can see down here, some people might have said number of passengers equals 255, right? And the problem with this is that there cannot be any spaces in the name of a variable. So oftentimes, in different languages, different programming languages, convention is slightly different. However, in Python, what we do is we replace our spaces with underscores. And usually, all of the text inside of our variable names, in this case, just our variable names, are lowercase. So for example, number of passengers here is perfect because it is all lowercase and has no spaces. So this is something I'm going to note here in a comment. So we want to have no spaces, and we also want to have a lowercase. And these are 2 points that are very, very important. The first one, if you actually include spaces, you will get an error in your code. However, if you if you make it uppercase or lowercase, it's not actually going to make a difference. However, this is the proper convention and something just to, if you start good practices early and now as you're learning, then that will carry through once you start coding a lot more. Setting the foundation with good naming conventions is very important. All right. And now the last thing here is also you cannot have any special characters. For example, don't include the percentage sign, the asterisk, the and symbol. Don't include special characters inside of your variable names. Make sure that it is just text. All right, everyone. So again, in this video, we talked about creating variables, and we also talked about getting the value of variables using the print statement or the print function and the type function to get the data type of our variables. And we talked about the 4 most common data types: integer, float, boolean, and string. In the next video, we're actually going to be talking about doing some very basic math with our numerical variables, which would be our integer and our float, such as addition, subtraction, multiplication, division, as well as changing the value of variables once you actually set them. All right, everyone, if you liked the video, feel free to like and subscribe for more content. Make sure to follow CADS on Instagram and join our Listerv to get the most up-to-date information on the organization. And see you all in the next one.